16 F20 F38 F1 /RC 32 R32 R /M32 F20 F38 F1 /RC 32 R64 R /M8 F2 Rex.W0 F38 F0 /RC 32 R64 R /M64 F2 Rex.W0 F38 F1 /RC 32 R32 R /M8 F20 F38 F0 /R added with X86-64. Instruction meaning noticed key sign extend DAX into RAXCQO sign extend RAX into RDX RAX compare string quade word CMPX CHG16 compare and exchange 16 bytes IRETQ 64-bit return from interrupt X jump if RCX is 0 exclude string quade word MOV SXD MOV with sign extend 32-bit to 64-bit POPFQ POP flags register PUSHFQ PUSH flags registered pred timestamp counter and processor ID SCASQSC and string quade words disk store string quade words WOX change GS base with kernel space MSR. Bit manipulation extensions added with ABM. LZCNT, POPNT, population count, advanced bit manipulation added with BMI1. ANDN, Bexter, BLSI, BLSMSK, BLSR, TZCNT added with BMI2. BZHI, Monks, PDIP, PEXT, RORX, SOX, SHRX, SHLX added with TBM. AMD introduced TBM together with BMI1 in its Pilot driver, 43, line of processors. Later AMD Jaguar and Zen-based processors do not support TBM. 44, no Intel processors, as of 2020, support TBM. Instruction description, 45, equivalent C expression, 46, BEXTR bit field extract, with immediate, SRC and GT start, and 1 and LT len, 1. BLCFILL fill from lowest clear bit X and X plus 1. BLCI isolate lowest clear bit X tilde, X plus 1. BLCIC isolate lowest clear bit and complement tilde X and X plus 1. BLCMSK mask from lowest clear bit X caret X plus 1. BLCS set lowest clear bit X plus 1. BLSFILL fill from lowest set bit X, 1. BLSIC isolate lowest set bit and complement tilde X, 1. T1 MSKC inverse mask from trailing ones tilde X plus 1. TZMSK mask from trailing zeros tilde X and X, 1. Added with command instruction set. Instruction opcode description POMOLCX reg XMMRM 660F3AM44 /RIG perform a careless multiplication of two 64-bit polynomials over the finite field GF 2K. PCLMULLQLQDX reg XMMRM 660F3AM44 /R00 multiply the low halves of the two registers. PCLMULHQLQDX reg XMMRM 660F3AM44 /R01 multiply the high half of the destination register by the low half of the source register. PCLMULLQHQDX reg XMMRM 660F3AM44 /R10 multiply the low half of the destination register by the high half of the source register. PCLMULHQHQDX reg XMMRM 660F3AM44 /R11 multiply the high halves of the two registers. Added with Intel ADX. Instruction description adds two unsigned integers plus carry, reading the carry from the carry flag and if necessary setting it there. does not affect other flags than the carry.adox adds two unsigned integers plus carry, reading the carry from the overflow flag and if necessary setting it there. Does not affect other flags than the overflow. Added with Intel TSX. Instruction opcode description begin real 16/32C7F8CW/CD start transaction. If transaction fails, perform a branch to the given relative offset.zen0F01D5N transaction.zab automate C6F8 if abort transaction with 8-bit immediate as error code.ZACIF2 instruction prefix to indicate start of hardware lock elision, used with memory atomic instructions only. For other instructions, the F2 prefix may have other meanings. When used with such instructions, may start a transaction instead of performing the memory atomic operation. X release F3 instruction prefix to indicate end of hardware lock elision, used with memory atomic /store instructions only. For other instructions, the F3 prefix may have other meanings. When used with such instructions during hardware lock elision, will end the associated transaction instead of performing the store /atomic. Added with Intel MPX. Intel MPX adds 4 new registers, BND0 to BND3, that each contains a pair of addresses. MPX also defines a bounds tables, a two-level directory /table data structure in memory that contains sets of upper/lower bounds. Instruction opcode description O test BMF30F1B /R make lower and upper bound from memory address expression. The lower bound is given by base component of address, the upper bound by 1s complement of the address as whole. Using RIP relative addressing not permitted, results in hash UD, BNDCLB, R/MF30F1AM/R check address against lower bound. Produces a hash BR exception if the bounds check fails. BQB, R/MF20F1AM/R check address against upper bound and 1s complement form BNDCNB, R/MF20F1B/R check address against upper bound BMDMOVB. B/M660F1AM/R move a pair of memory bounds to / from memory or between bounds registers and move B/M. B66F1B/R BNDLDXB MIB0F1AM/R load bounds from the bounds table using address translation. Using ANSI addressing expression MIB requires memory addressing modes that use the SI bit. Produces a hash BR exception if bounds directory entry is not valid, which prevents address translation. BNDSTX MIB B0F1B/R store bounds into the bounds table using address translation using ANSI addressing expression MIB BNDF2 instruction prefix used with certain branch instructions to indicate that they should not clear the bounds registers. If the preserve config bit is not set, then branches without this prefix will clear all 4 bounds registers. Added with Intel CET. CET adds 2 distinct features to help protect against security exploits such as return-oriented programming, a shadow stack, CET_SS, and indirect branch tracking, CET_IBT. Instruction opcode description notes and XPTR32F30FA/5 increment shadow stack pointer shadow stack. CET_SS. When shadow stacks are enabled, return addresses are pushed on both the regular stack and the shadow stack when a function call is made. They are then both popped on return from the function call. If they do not match, then the stack is assumed to be corrupted, and a hash CP exception is issued. The shadow stack is additionally required to be stored in specially marked memory pages which cannot be modified. Binormal memory store instructions. X64F3 rex.w0fa/5 RDSSPDR32F30F1E/1 read shadow stack pointer into register, low 32 bits. RDSSPQR64F3 rex.w0f1E/1 read shadow stack pointer into register, full 64 bits. Save eprefs 30F01EA save previous shadow stack pointer RSTORSSPM64F30F01/5 restore saved shadow stack pointer WRSSDM32R320F38F6 write 4 bytes to shadow stack WRSSQM64R64 rex.w0f38F6 write 8 bytes to shadow stack WRUSSDM32R3266 0F38F5 write 4 bytes to user shadow stack WRUSSQM64R6466 rex.w0f38F5 write 8 bytes to user shadow stack SETSBSYF30F01E8 mark shadow stack busy CLRSSBSYM64F30FA/6 clear shadow stack busy flag ENDBR32F30F1EFB terminate indirect branch in 32-bit mode indirect branch tracking, CBT_IBT. When IBT is enabled, an indirect branch, jump, call return to any instruction that is not an NBR32/64 instruction will cause a #CP exception. NBR64F30F1EFA terminate indirect branch in 64-bit mode, no mnemonic. 3E prefix used with indirect. Call /JMP near instructions, opcodes FF/2 and FF/4, to indicate that the branch target is not required to start with an NBR32/64 instruction. Prefix only honored when O_track_EN flag is set. This prefix has the same encoding as the DS segment override prefix as of April 2022. Intel documentation does not appear to specify whether this prefix also retains its old segment override function when used as a no-track prefix, nor does it provide an official mnemonic for this prefix. 47, 48, new by Nutils use not track, 49. X87 floating point instructions. Original 8087 instructions. Instruction meaning notice 2xm1 more precise than 4x close to 0. On 8087, only supported 4. On 80387 and later, supported 4. FABS absolute value FADADVAD pad and POPF load BCD FBSTP store BCD and POPF change sign flex clear exceptions compare fcomp compare and POPF compare and pop twice if text decrement floating point stack point of disable interrupts 8087 only. Otherwise FNOP div divide Pentium div bug div divide and pop div divide reverse div divide reversed and pop enable. Interrupts 8087 only. Otherwise FNOP FFRE free register field integer add for com integer compare for comp integer compare and pop phi dive integer divide fidiver integer divide reverse seed filed load integer final integer multiply fix increment floating point stack pointer finite initialize floating point process or fist store integer fist store integer and pop phi sub integer subtract phi sub integer subtract reverse seed fold floating point load FLD1 load 1.0 on 2 stack fold cloud control word fold and load environment state fold and load environment state 16-bit FLDL2E load log 2 E on 2 stack using round to nearest rounding on 8087. Performing rounding based on rounding control on 80387 and later. FLDL2T load log 2 10 on 2 stack FLDLG2 load log 10 2. On 2 stack FLDLN2 load LN. 2. On 2 stack fold pi load pi on 2 stack folds load 0.0 on 2 stack fma multiply and pop flex clear exceptions. No wait dies disable interrupts. No wait 8087 only. Otherwise FNOPFNENI enable interrupts. No wait 8087 only. Otherwise FNOPFNINIT initialize floating point processor. No wait FNOP no. Operation from save FPU state. No wait. 8-bit from save FPU state. No wait 16-bit from store control word. No wait from stenv store FPU environment. No 8 from stenv store FPU environment. No 8. 16-bit from store status word. No wait pattern partial arctangent computes. With adjustment for quadrant similar to CSATN2. Function. On 8087. Only supported for. This restriction was removed on the 80387.FPREM partial remainder computes remainder with same sign as dividend, which is not IEE compliant. May compute a partial remainder, in which case it must be run again, signaled by C2 flag register. FPTAN partial tangent on 8087, only supported for on 80387 and later. Supported for FRNDINT round 2 integer for store saved state for store saved state perhaps not actually available in 8087 FSAVE save FPU state F save FPU state 16-byte scale by factor of 2 FSQRT square root floating point store store control word stenv store FPU environment. FSTENVW store FPU environment, 16-byte store and pop store status word subtract and pop reverse subtract and pop dist 40 way while FPU is executing examine condition flags checks change registers extract exponent and significant FYL2XY times log 2s if y equals log 2. Then the base B logarithm is computed FYL2XP1y times log 2, x plus 1, more precise than log 2z if x is close to 0. Only supported for. Added in specific processors. Added with 80287. Instruction meaning notice FSEPMS a protected mode 80287 only, otherwise FNOPS say X store FPU status word into CPU register. Added with 80387. Instruction meaning notice FLOD and float environment state. 32-byte save FPU state 32-bit FPREM1 partial remainder computes IEE remainder first addressed or saved state. 32-byte signer compute and forward slash or dot due to argument reduction being done with only about 68 bits of precision, is not precisely 1.0, but instead given by dot 50, 51. This argument adjunction inaccuracy also affects the FTN instruction. Cos cosine Fsin cosine and cosine Fsten store FPU environment. 32-bit few commune ordered compare few compune ordered. Compare and pop few compune ordered compare and pop twice. Several 80387 class coprocessors provided extra instructions in addition to the standard 80387 ones, none of which are represented in later processors. Instruction opcode description available in first F4, 52, or DBE5. 53. FPU reset protected mode. Instruction to signal to the FPU that the main CPU is exiting protected mode, similar to how FSEPM instruction is used to signal to FPU that the CPU is entering protected mode. Different sources provide different encodings for this instruction. Intel 287XLFNSTDWAXDFE1 store FPU device word to AX Intel 387SL 53, 54, FNSTSGAXDFE2 store FPU signature register to AX 0 DBE8 select coprocessor register bank. 0 lit 2 C87, 3 C87, 53, 55. FSBP1 DBEB select coprocessor register bank 1 FSBP2 DBEA select coprocessor register bank 2 FSBP3 DBE9, 56. Select coprocessor register bank 3, undocumented, F4X4 FMAL 4X4